okay. He said I can tip it over. It'll go to sleep now. It won't come on anymore, but we'll see what happens. Anyway, it's a pleasure to welcome you out tonight to hear Dr. Amstrup. He's chief scientist now for Polar Bears International. He's also adjunct professor at the University of Wyoming in Laramie, but we're not going to hold that on him. We don't play him in football anymore, so it's okay. We can kind of move on. Before he joined PBI, Steve was the research wildlife biologist at the USGS in the Alaska Science Center, where we both worked. He had been there for 30 years and myself just 10. Steve was also my supervisor, so I can't seem to escape him, but that's a good thing because he's a lot of fun to be around. Steve earned a Bachelor's of Science in Forestry at the University of Washington, a Master's of Science in Wildlife Management from the University of Idaho, and a PhD in Wildlife Management at the University of Alaska Fairbanks. He led research on all aspects of polar bear ecology in the Beaufort Sea between 1980 and 2010. Steve's the past chairman of the IUCN Polar Bear Specialist Group and has been an active member of the IUCN Polar Bear Specialist Group for over 33 years. His particular interests include the distribution and movement patterns of polar bears, as well as population dynamics, how information on those topics can be used to assess wise stewardship. Steve's particularly interested in how science can help to reconcile on those topics and how it can be used to assure wise stewardship. He's particularly, I've read that twice now, but just in case you missed it the first time, he's particularly interested in how science can help us reconcile the ever-enlarging human footprint on the environment with the needs of other species for that same environment. Prior work experiences include studies of black bears in central Idaho, pronghorns, grouse in Wyoming. On his honeymoon in New Zealand, he and his wife Virginia helped in tagging little blue penguins, and Steve said that gave him the honor of being one of the very few people on planet Earth to have been bitten both by polar bears and penguins, which occupy only the southern hemisphere, of course. Steve has authored or co-authored over 130 peer-reviewed articles on polar bears and other large mammals, and he's the senior editor of a recent text on population estimation methods. Importantly, in 2007, he and a team of USGS research scientists produced 9 reports that were instrumental in convincing the U.S. Secretary of Interior that polar bears should be declared threatened under the Endangered Species Act, which of course they were. Most recently, Dr. Amstrup led an effort showing polar bears are not unavoidably doomed, and in the December 2010 issue of Nature, he and his co-authors showed that preserving polar bears is all about controlling man-caused temperature rise. In recognition of his conservation impact, he was also selected as the 2012 recipient of the Indianapolis Prize for Animal Conservation, and in 2012 also the Bambi Award in the Our Earth category for efforts of animal conservation. With that, I welcome Dr. Steve Amstrup. Thank you.
Thank you, Tom, and thank you, Dr. Sinclair, and thank you all for coming. It's my pleasure to be here. You know, Tom has talked with me over the period of the last several years, ever since he came down here.
Each mic a little higher, maybe, or a little lower.
Testing.
Oh, there you go.
I didn't have it on.
There you go.
So shall I start over? Tom and I had been talking about me coming down here to give a talk for a long time, and it's nice to finally have that happen. And by coincidence, the timing is such that Catherine Hayhoe, some of you may have heard her speak earlier this evening, is here, and I'm going to have an opportunity to meet with her in person tomorrow for the first time. And then I'm meeting with the LDS stewardship community in the evening. Tom and I are going to meet with them. So I'm really grateful for all of these opportunities. Didn't mean to do that. So polar bears is part of the topic that I'm going to talk about, but it's not the whole thing. I'm going to talk about global warming. I think of it and how I think it's important for people to think about the topic and avoid some of the confusion that's out there about it. Oops, I didn't want to do that. and I want to emphasize that it's not just about polar bears, so I'm going to be talking about a few other things, and things that some of you might feel are a lot closer to home. I'm going to talk about, if you read the press about climate, maybe it'll be okay. What we can all, a little about me. You heard some background from both Tom and Larry, but I feel like I'm a really lucky man. I'm one of the few guys I know who actually has been doing for my whole life what I wanted to do when I was a little kid. I grew up watching Marlon Perkins on TV and reading Field and Stream, and I wanted to be a wildlife biologist. And I was always captivated by bears and wanted to go into the field and study bears. I remember one of my aunts, every time I would see her, she lived in a different town, she'd come up to me and tap me on the head. "Well, Steve, do you still want to go into the woods and study bears?" "Yep." That's what I wanted to do, and I felt very fortunate. I did my master's work on black bears in central Idaho, and took a short hiatus from bears. Did 5 years in Wyoming working on pronghorn antelope and sharp-tailed grouse. But then in 1980, I took over the polar bear research project in Alaska. And I was there for 30 years. Started when I looked a little younger than I do now. Spent a lot of time going out on the ice, catching bears, re-catching bears, measuring them, re-measuring them, weighing them, putting radio collars, the whole bit. We looked at almost all aspects of polar bear ecology and learned a lot about polar bears. In 2010, after we published our paper in Nature, it occurred to me that although there were still a lot of really interesting research questions to be answered, we already knew the answer to what we needed to do to save polar bears from extinction. And so I decided at that point to leave hardcore research and go join a group called Polar Bears International, a very small non-governmental organization with the goal of saving polar bears by saving their sea ice habitat. Now, most of what I do is speaking to groups like this. This is me talking in Moscow, Russia last winter. These are the environment ministers from all of the polar nations. You'll notice I'm wearing the same tie. In fact, I think I'm wearing the same outfit altogether. I only have one. Actually, it's a different shirt. And I do a lot of media interactions and things like that. So before I get started about polar bears, I also want to thank the crew that I worked with in Alaska. I've been really fortunate in my career also to have been able to work with great teams of people that brought different skills, different knowledge sets, and combined we were able to really do a lot. Similarly, the team that I work with at PBI is a small team, but everybody's hardworking, and we feel like we're really accomplishing some things. And I need to thank a lot of organizations that either in the past or currently have funded the work that I've done and the work that my collaborators have done. So, why should we care about polar bears? Well, for one thing, they're really cool. The polar bear is the largest non-aquatic predator on Earth. They have feet the size of platters. They have a 45 or 50-inch neck. They can be over 10 feet long. And a large adult male can be nearly 5 feet tall at the shoulder when standing on all fours. So I can tell you, if you're down on the ice doing some work and one of those big guys walks up on you, they look as big as a house. But despite their large size as adults, like all members of the bear family, they start out small and vulnerable. Polar bears have many fascinating behaviors. One of the most sought-after behavior to observe in polar bears is the sparring that they do on the coast of Hudson Bay in the fall of the year. And this is something that has occasionally been observed elsewhere in the range of the polar bear, but it's been fairly predictable there. And so I'm sure many of you have seen photos like this, except perhaps a better quality. That one happens to be one of mine. This is one of the things that people really seek when they go out to photograph polar bears. We found that they had lots of other interesting behaviors, but we couldn't alter them very much. This is an ambitious helicopter mechanic trying to teach a polar bear to roll over without a whole lot of success. Polar bears have the greatest degree of sexual dimorphism of all of the members of the bear family. That means that the males are much, much bigger than the females. And this is a great example. This is the remains of a bowhead whale on the beach of northern Alaska. And this is a bunch of subadult and adult female polar bears. And this big male walked up and started feeding, and he almost made the others look like a toy. Adult males can weigh 1,000 to 1,200 pounds, and the females are typically 500 or 600 pounds. The males are 50% taller and twice as heavy. Polar bears, in addition to being the largest of the four-legged predators, are the most mobile of all quadrupeds. The radiotelemetry work that I did over the years documented tremendous movements. And this slide just shows an example of a bear that we followed for a little over 2 years. And by comparison, some of you have probably heard of the great migration of the porcupine caribou herd. Anybody ever heard of that? Well, that whole migration occurs in an area about like this. And it's considered one of the great animal migrations of any place. These animals are just incredible, with home ranges the size of 3 times the size of the state of Utah. We also discovered, as sea ice retreated from the coast of Alaska, that polar bears had incredible swimming abilities. And this slide shows one example. This is the longest swim we ever recorded from a radio-collared bear. Between 26 August and 4 September, this bear swam 387 kilometers, or almost 500 miles. Open ocean all the way. Now, it wasn't without cost. She lost 20% of her body weight and also lost her yearling cub. So I wouldn't want to give you the impression that as the sea ice retreats, oh, polar bears are going to be fine because they can swim. But they do have incredible capabilities. The polar bear is the most recent of the bears. The molecular genetics evidence suggests that they evolved separated from a common ancestor with the brown bear about 1 million years ago or less. And we're not really sure how much less it might have been. But regardless of that, it makes them the most recent of the bears. And when they separated, they apparently saw an empty niche out on the sea ice and took to the sea ice as a home. Currently, polar bears occur in 19 subpopulations around the top of the world. And this is the kind of a map that polar bear scientists usually look at. The North Pole is right there, the Arctic Basin, the ring of continents around the Arctic Basin. Here's Alaska, northern Canada, Greenland, Russia, and the polar bear populations defined there. There's 19 recognized populations or management units. Now, in 2007, when the Secretary of Interior challenged my lab to come up with predictions for the future of polar bears, I thought, well, we can't deal with 19 populations. And I looked at movements of sea ice, the melting, the freezing, and the motion once the ice was formed, and realized that we could probably consolidate those into 4 major ecoregions that are shown here. And basically, polar bear management now and monitoring plans for the future are oriented around those 4 major ecoregions of polar bear habitat. But regardless of which ecoregion we're talking about, this is where polar bears make their living. This is their habitat. And classic sea ice habitat in the southern Beaufort Sea in the month of April. There's the bear. It looks more like the surface of the moon than most places that we would think of as habitat. When you first fly out there, it's just like, how could anything live out here? But not only do they live out there, they've become the largest of all the bears, the largest of all the 4-legged predators. They use the sea ice for almost all of their life history needs, but the most important need is feeding. They could probably do just about everything else on land, but we know that they need the sea ice to feed, and they feed mainly on two species of seals. The ring seal, these are about 150 pounds as adults. They're called ring seals because of the ring-like pattern in their fur. And the bearded seal. Bearded seals are called that for obvious reasons. And these are enormous animals. They can weigh 700 or 800 pounds. The evidence suggests that it's typically adult males that most frequently catch bearded seals because they're so big. The food chain in the Arctic is very simple. It starts out with algae and diatoms growing on the underside of the sea ice. Those are fed upon by shrimp-like creatures, which are fed upon by fish. Seals eat the fish, polar bears eat the seals. Relatively simple, straightforward, all dependent. The whole ecosystem is supported by what we call the epontic community, the community of algae and other small organisms that lives on the underside of the sea ice. Polar bears catch seals by sneaking up on them when they're hauled out breathing holes like this seal is. Or the classic that we think about polar bear hunting is a still hunt where they sit at a breathing hole waiting for a seal to show its face. And I have to think that if you're a ring seal, it must be a terrifying life. You're an air-breathing mammal. You're living under a platform of ice. You have to come up through these little holes, and you never know if there's going to be a bear up there. In the spring of the year, ring seals create subnivean or under snow layers. These are little caves that are above the surface of the sea ice but below the surface of the snow. And it's in these caves that they give birth to their white-coated pups. This is my wife, Virginia, one time that she was out with me and we found an abandoned pup on the ice. Otherwise, these pups are kind of hard to get pictures of. Polar bears have become very adept at finding these structures and removing their occupants. So if you're a ring seal, this indeed is your worst nightmare. But it's the high-fat diet of these marine mammals that has allowed the polar bears to become as large and as numerous as they are. Ring seals and bearded seals both can be 50% or more fat by total body weight. So they're like these giant fat pills laying out there on the ice for polar bears to feed on. We have a paper that's coming out next week talking about that fact and the fact that there just isn't sufficient food on the terrestrial side of the Arctic to feed big bears like this. The energetics just don't balance. So the sea ice is declining, and I know everybody here has heard of that. I talked with some folks in the audience earlier about that. A lot of news about the sea ice declining. What does it look like? Well, this is an example from 2012, a couple years ago, which was the record sea ice retreat thus far. This gold line is the mean sea ice extent for the period of 1979 to 2000, which was already a declining sea ice extent compared to historic records. But by comparison, the area that was lost that year is about 15 times the size of the state of Utah. A lot of habitat. What does that look like graphically? Here we have the sea ice extent on this axis, time on this axis. We've been losing about 13% per decade of sea ice extent in the Arctic ever since the satellite record started to be tabulated. Now, some of you may have heard, has anybody heard of the Great Sea Ice Recovery of 2013? Anybody read the news reports about that? It made some press that 2013 was actually a great recovery year after the record retreat of 2012. Well, that recovery was actually still below the 2005 extent, which was at that time the all-time record low sea ice extent. There is no ongoing sea ice recovery. The sea ice declines in a linear fashion with linear but inverse relationship with temperature, and the sea ice is continuing to decline. The 2014 level was right there, so just about on the average extent or the average trend line for the last 30 years. What does the future look like? Well, this is a little animation that was created by the National Center for Atmospheric Research, and it'll take us through September sea ice beginning in the early 1900s and taking us to the end of the 2100s. And so I'm going to, it runs very, very fast. You'll see the dates scrolling by here, and compare the years in the early part of the record to the years in the latter part of the record. Now, of course, nobody is yet measuring what the sea ice extent is going to be in 2100, so this is obviously a mathematical projection. But there's been a number of them, and they all look something like this. So my concern is that if I was a female polar bear trying to find food for my cubs, where would I go in the summer of 2100? Bringing it a little bit closer to home, this slide shows the sea ice extent north of Alaska during the first 4 years that I worked there and the last 4 years that I worked there. So 1980 through 1984, 2007 to 2010. Sandwich those together, you can see there's quite a profound difference. When I first went to the Arctic, I could stand on the beach of northern Alaska in the summertime and see the sea ice. If I had a good spotting scope, I might even see a polar bear out there patrolling for seals. Now I can't see the ice at all. It's beyond the curvature of the Earth. What does that mean for bears? This slide, the gold dots are some of our radio telemetry locations from the month of September during the early period of satellite observation, of satellite radio collar observations. And you can see that most of those dots are in places where there's no longer any sea ice. The bears like to be near shore in that productive shallow water. They don't like to be way offshore. Due to the sea ice decline, we've seen a number of different negative things. Changes in movements, changes in feeding patterns, including increased levels of cannibalism. And Tom was involved in discovering a really grisly scene of where an adult male polar bear was actually hunting in a denning area on land. There was no other food for it there, but it was going along the bluffs until it found a female in a den, dug into it, and killed her. And Tom was the first one on the scene, I think. Anyway, lots of unusual things, but the most important thing that we need to focus on is declining reproduction and survival, because those vital rates bear directly on changes in population size. And when scientists say that polar bear survival rates are declining, what they mean is that more polar bears are starving to death. And starvation is not a pretty picture. In December, we published a paper, my former colleagues at the USGS and I, documenting that during the first decade of the 2000s, that the population of bears that I'd been studying for 30 years had declined by 40% just within that decade. Not a very pleasant publication. In 2007, in response to the Secretary of Interior's request, we put together a series of 9 reports. I wrote a synthesis of those reports projecting that by the middle of this century, by around 2050, if we stay on our current greenhouse gas emissions path, we could lose 2/3 of the world's polar bears. And by the end of the century, we might lose them all. Now, when we made those projections, there were some people that said, well, you know, we can't even predict next week's weather. How could you predict a future for polar bears that's 50 years or 100 years out? And that has to do with the inevitability of the path that we're on. So I'm going to talk a little bit about how global warming works now, and many of you probably know this, but I've encountered a lot of people who don't really quite understand it. The Earth is warmed by the sun. Shortwave radiation comes in, warms the Earth crust, warms us if we're standing out in the sun, warms the buildings here on campus. But that heat can't stay on the Earth. It has to escape back into space. If it didn't escape back into space, soon the Earth would be just a ball of hot gas. The estimated temperature of the Earth just over the last billion years of solar insolation, of solar energy reaching the Earth, is 800,000 Kelvin. Clearly not suitable for life. So the Earth is constantly trying to maintain its energy balance with space, greenhouse gases like carbon dioxide, water vapor, methane, those gases are not entirely transparent with regard to long-wave radiation, and that's how the Earth tries to cool itself. That's the energy you feel after a hot day if you put your hand at sunset over a paved street, and you can feel that it's hot down there. That's that heat radiating in the form of long-wave or infrared radiation. We've known this for a long time, and if we add more greenhouse gases to the atmosphere, the Earth has to warm. It prolongs the retention of that heat. It's basic physics. It's the same physics that regulate the flight of the aircraft that I flew down here in. It's the same physics that regulates the path of the bullet that I shoot from a rifle when I'm deer hunting. It's the same physics, conservation of energy, mass, and momentum. Now, it's not a new discovery. We've known about this for about 200 years. In fact, as early as the turn of the last century, there were two fellows, Svante Arrhenius in 1896 and Guy Callendar in 1939, who actually did handwritten models of how much the Earth might warm if we double the CO2 concentration on Earth. One of them estimated that it would be 4 to 5 degrees, or 5 to 6 degrees, and the other one estimated it would be 2 degrees. And that's about what the estimates are now from the most comprehensive, complicated models that we have. We've known about this for a long time. It just wasn't controversial until recently. But we always hear about not that certainty of the physics, but the uncertainty of climate change. Well, what is all that uncertainty? And here I find that a lot of people really don't quite understand what that uncertainty is. So I'd made a little drawing. There's no data here. This isn't a graph, it's a drawing. But it's a drawing that has temperature on this axis, time on this axis, and you can think of these swings here, the large-scale curve, as changes in the climate. Changes in the climate that might be caused by volcanic eruptions, by El Nino or La Nina, or shifts in the Atlantic decadal oscillation, or a change in the pattern of the North Atlantic drift. These things change regional and even global temperatures over time, and often over long time scales of a year up to a couple of decades. Over the top of that, we have weather. Smaller scale changes that occur, shorter duration, big snowstorms, things like that. But the most important thing is that for about the last 10,000 years, if you average all of those fluctuations, the small ones and the big ones, it's been a pretty flat line. As greenhouse gas concentrations in the atmosphere continue to be elevated, all of those fluctuations continue to occur, but they occur over a higher and rising baseline. So here's the uncertainty, but this is the certainty. So, and another way to view that is, well, we might not know exactly how steep that line is. Is climate sensitivity 2 degrees or is it 5 degrees? So maybe there's some brackets around that. But that's the uncertainty. The trend is very certain. So to me, when I think about the risks of climate change, I think that the only reason I would worry about that uncertainty is if I didn't care what kind of a future I'm leaving for our children. Because it's going to catch them sooner or later. Now, I was really interested. Clara Desser at NCAR came up with a paper in 2012. I'd been using that drawing for a couple of years in talks, and she came up and did climate model projections of the future for various parts of North America. I'm not going to dwell on this, but it looks pretty similar. There are some brackets, and there's a lot of fluctuation, but all of the curves are going up. That was summer, this is winter. There's nothing that suggests that the Earth is going to cool as long as we are on the current path. Here's a few headlines that have been in the paper just within the last couple of weeks. California enters the 4th year of drought with its first rain-free January ever. There's record sea lion strandings on the coast of California, hundreds and hundreds of starving sea lions. Between 50,000 and 100,000 Cassin's auklets dead on the beach Olympic National Park sitting at 4% of its normal snowpack for March. And in the department of, well, what's my concern about it is our ski area was closed all winter because we didn't have any snow. Is this global warming? Scientists debate, well, how much of that is that natural fluctuation? How much of it is the human forced trend? And we're not absolutely sure about any of these things at this point in time. But what we are sure about is that that's what global warming looks like. And I think most of us don't like it. With greenhouse gas forcing continuing to elevate the Earth's temperature, the past is no longer a good view of the future. It used to be that, farmers knew, ranchers knew that the weather was a little bit different every year, but overall they could generally anticipate certain things would be the same based on all of the prior years. That's not true anymore. And the discussion of, well, how much of this is attributable to climate change that's forced by humans versus how much is natural variation is largely because we're probably still down here on the curve, where we're still in that range where the natural fluctuations overlap what they might otherwise have been without the greenhouse gas forcings. The great climate scientist James Hansen said that it would probably, he said this back in the mid-1980s, that the real clear climate change signal probably wouldn't be registered as obvious until after about the first decade of the 2000s. And that's where we are right now. Well, we hear a lot about, well, couldn't solar cycles be causing changes in solar energy reaching the Earth be causing this situation? And this is a slide that I actually got from Catherine Hayhoe showing the increase in temperature and over the last 50 or 60 years, the declining energy reaching the Earth from the sea ice. In fact, if you go back to the last 6,000 years of the Earth's history, this is what it looks like. Carbon dioxide relatively flat until very recently. Temperature declining steadily because of the Earth's orbit around the sun. We're actually gradually on our way towards another glaciation, or we would be, except for greenhouse gas emissions. And so we've been seeing gradually declining temperatures for the last several thousand years until very recently. Another question that I've gotten is, well, but maybe there's some other reason that we're experiencing this increase in CO2 in the atmosphere. And we know that the CO2 in the atmosphere is coming from fossil fuels because of a couple of different things. And these relate to the isotopes of carbon. Anybody here know about radiocarbon dating? Have you ever heard of that term? Where fossils are aged by what the concentration of carbon-14 is. Well, there was a scientist, a physicist named Hans Suess, who was working on radiocarbon dating in the 50s. And he was looking at fairly recent samples, and he was looking at ancient samples of animal and plant tissue. And he couldn't, things didn't just quite jibe. We know with pretty good clarity what the normal concentration of carbon-14 is in the atmosphere because we understand how cosmic waves enter the Earth's atmosphere and create it. And he realized that something wasn't quite right. Well, he figured out that what wasn't quite right was that we were depleting the atmosphere of carbon-14 because fossil fuels, by definition, don't have any carbon-14 in them. They're all older than the half-life of carbon-14. Carbon-13 is kind of a similar boat. Plants have a lower concentration of carbon-13. Carbon-13 is a stable but rarer isotope of carbon than the normal one, carbon-12, and it's isotopically differentiated in metabolic processes. So plants are poorer in carbon-13. Fossil fuels are made of plants. They're poorer in carbon-13. So the Suess effect applies to carbon-13 as well. And by the way, note that this is not the Cat in the Hat Suess. It's a different guy. So the carbon-14, the carbon-13 depletion, and then the other thing that we see right in concert with this is a gradual decline of oxygen in the atmosphere. Because when we burn something that's a carbon-based fuel, we oxidize the carbon. Now that carbon is combined with two oxygen molecules that used to be floating around by themselves. So unabated climate warming ultimately will eliminate polar bears. None of my colleagues have any doubt about that. But it doesn't have to be that way. The paper that Tom mentioned in his introduction of me, we showed very clearly that it's all about controlling temperature rise by controlling greenhouse gas emissions. As an example of the gains we could make, this is a scenario that we ran, a climate model that we ran, where we looked at the business as usual projection, in which September sea ice went to approximately 0 by the middle of this century. And we said, well, what would happen if we stopped emissions at the 2020 level, stopped the growth of emissions and stabilized them at the 2020 level? And sea ice responded within a period of about 25 years, actually quicker than we thought it might, and then stabilized at a much higher level. What that looks like on a map, and again, this is one of those top-of-the-world maps, is look at the contrast the red with the dark purple, looking at the end of this century and looking at the summer months, there's almost no red in the business as usual scenario, kind of like that projection, that movie I showed you a little bit ago, but there's lots of purple, a lot more polar bear habitat. So we know we can make a difference for polar bears. And there's a lot of people out there, I haven't gotten into this literature, but there's a lot of literature out there where people have documented how we can do this, that we have this within our ability. It's not trivial, but we have it within our ability to get to a sustainable energy economy. Polar bears depend on a habitat that literally melts as temperatures rise, and so they're an early indicator of the habitat losses caused by climate warming. So, just thinking about polar bears, there's a good reason that we should care about them. They're really cool, they're indicative of their ecosystem health, and we're creating the problems that they're facing, and we can make a difference for them. But what if you don't care about those far away and cold places? Well, does anybody think it's warmer here than it used to be? The climate records here were not quite as complete as they were for Salt Lake City, so I plotted Salt Lake City mean temperatures for the last 120 years, and you see a pretty steady rise. If you look at it seasonally, most of that rise is in the late winter and the summer. Winter temperatures here are almost 2 degrees warmer now than they were at the beginning of the last century, and summer temperatures are over 2 degrees warmer than they were. 2 degrees maybe doesn't sound like much if you're thinking of an individual day and whether it's 90 or 92, but if that's the average temperature, it makes a big difference. Now, we've talked about what temperature rise means for polar bears and their habitat, but what about something closer to home, like in the mountains right above town here? The pika is probably as much an indicator of the impact of a warming environment as the polar bear is. They are to the alpine environment what the polar bear is to the Arctic environment. Eric Beaver, a colleague of mine at the USGS, has been studying pikas for a long time, and he's gone back into the fossil record and shown that by looking at the minimum elevation in the Great Basin, so Utah, Nevada, and Eastern California, where do pikas occur? And the minimum elevation that they occur at has been rising steadily. Now, these are early records right at the end of the last ice age. These are more recent, and from the mid-Holocene, 5,000 years ago or so, up until the middle 1900s, there wasn't a whole lot of change. But in the last several years, we've seen the minimum elevation at which pikas occur in the Great Basin rising steadily. And my concern is, what happens when the minimum elevation that's suitable for pikas is there? And of course, it's not just about pikas. Pikas are also a really good example of what we might call the difference between climate change and global warming. Climate change is all of the symptoms that we might see as a result of warming the world. And one of the things that Eric discovered in his research was that summertime, warmer mean summer temperatures were killing pikas by drying out their habitat and eliminating the food that they relied on during the course of the summer and that they stored for the winter. Warmer wintertime average temperatures meant more precipitation was falling as rain, and what snow did fall didn't persist as long, but there were still those natural fluctuations in the weather, and if a cold snap occurred when there wasn't any snow on the ground, the pikas would freeze to death. So global warming was also killing pikas by freezing them to death. And that's also been documented now with Alaska yellow cedar. In the panhandle of Alaska, there's 500,000 acres of now dead Alaska yellow cedar. These are majestic, wonderful trees with terrific wood. They have a shallow root system, and historically, they were able to survive in this environment because snow covered their roots, deep, deep snow. And so if there was really cold weather, they were insulated from that cold. But with slightly warmer average temperatures, the snow isn't there as long, and then if a cold snap occurs when it's bare ground, it kills the trees. So another example of global warming killing an organism by freezing it. It's not just about North America. Another mountain situation, this is the mountain Visacha. They live in the Andes in a similar situation to our pikas. And they're also the principal food of the Andean cat, the single most endangered of all the American cats. These animals live in this area just south of just below elevation of the snowfields and glaciers in the Andes. And these are among the most rapidly disappearing glaciers. Jim Sanderson's been studying these animals. He was a physicist at Sandia Labs before he decided to try and become a conservationist. And I said, well, what's the impact of global warming that you anticipate on Andean cats? He said, glacial melt equals grass equals Visachas equals Andean cats. No glaciers. I don't even need a model to project what's going to happen. I was talking with Patricia Wright, who's for the last 40 years been studying lemurs in Madagascar, and she's been instrumental in protecting lots and lots of acres of forested habitat in Madagascar. But now she's concerned because she's seeing it dry out and be impacted by rising temperatures. So all the work that she's done for her whole career, she's concerned about going down the drain before her lifetime is over. Lori Marker's been studying cheetahs in southern Africa for 40 years, has saved hundreds of thousands of acres of habitat, and now with warming temperatures, it's being converted from grasslands that are suitable for cheetah hunting to acacia shrublands, which they can't run through to pursue their prey. And when they do try and run through it, it scratches their eyes out. These acacias are incredibly adapted to a drier, warmer climate. This is one that's been excavated, a tiny little bush, and look at the extent of that root system. I'm sorry it's a poor quality photo, but you can see that there's very little room for something else to compete with that species. And this brings up another topic of what we often hear about the winners and losers of climate change. Acacia mellifera is a real winner, and cheetahs in that equation are losers. This is a brown Argus butterfly. There was 2 or 3 years ago, there was a lot of press about how this butterfly, which traditionally occurred only at the very southern end of the British Isles, was suddenly burgeoning up through the British Isles, about halfway up England, and expected to continue to advance. It was a great thing. People were hailing it as a winner of climate change. Nobody ever talked about, well, if it continues to get warmer and warmer, pretty soon they'll wink out at the top of Scotland. They weren't thinking far enough ahead. And they also weren't thinking about, would they be as excited if this was a different arthropod, like the mountain pine beetle? They're a winner in climate change. This is affecting all species and all ecosystems. And it's not just about animals. It's about people too. And the people who are going to be the soonest and the most severely impacted are the people with the fewest resources and those living closest to the land. The IPCC has a way of ranking its projections. Unlikely, as likely as not, very likely, etc. They have really refined definitions for each of these terms. So if you say very likely, there's like a statistical boundary for that. But if you add up all of the projections, it's clear to me that increased hunger is virtually certain. And whether we care about those people or not, and I think everybody in this room does care about those people that live in some of those faraway places that are hard to pronounce. But even if we don't, we know that hungry people can't do conservation. So it's all balled up together. And eventually it's not just those living closest to the land. A colleague of mine at the USGS was mapping last interglacial coastlines. During the last interglacial period, 120,000 to 130,000 years ago, it was about 1 degree Celsius warmer than it is now, nearly 2 degrees Fahrenheit. This was the coastline of Florida. This isn't a computer model. This is the mapped coastline of Florida when it was 1 degree Celsius warmer than it is now. We could be 2 or 3 degrees warmer by the end of this century. Now, there's a lot of people debating about, well, you know, sea ice, or glacial ice sheets can't respond very quickly, so maybe we'll only see 1 meter or 2 of sea ice or of sea level rise by the end of this century. But don't we care about beyond the end of this century? A prolonged period of 1 degree would displace millions of people just in Florida alone. I had an interesting experience. In February, I was asked to give a series of lectures in North Carolina, and I found out when I got there that North Carolina is one of the states that has outlawed talking about global warming. And they also, I found out when I got there, they had outlawed sea level rise. And it's not really clear to me how that's going to work, but if we don't do anything else, and in a couple of 100 years, it looks like that, maybe they're onto something. Global warming turns all of our conservation and humanitarian efforts on their heads. We can't build a fence to protect the sea ice from rising temperatures or to protect the talus slopes that are the home to the pika, or to protect the Namibian grasslands from acacia invasion. A fence won't do that. But we know what we can do. Albert Einstein said, "Those who have the privilege to know have the duty to act." We all know, and our leaders know, they just don't want to admit it. So how can you help? Well, this is the point in the talk when somebody who works for a nonprofit says, "Donate now." And by all means, I would really like all of you to join Polar Bears International and increase our voice. But what I really want you to do is to use whatever influence you have to convince our leaders that we want a future that's desirable, that this is an unsustainable pattern that we're in now. Carbon-based fuels have brought us wonderful things, but there have been some serious unintended consequences. We know what those are now. We have the ability to deal with them. So the most important reason that we should care about polar bears is because they're a messenger of the challenge and hope that faces us all. Mike Crowther, the director and CEO of the Indianapolis Zoological Society, says that as conservationists, our goal should be to leave a world that our children would choose rather than one that they're forced to endure. If we act to mitigate the rise in greenhouse gases in time to save polar bears, we will leave a world that future generations would choose, whether they're future generations of animals or people. I'm going to stop there, and I'd be happy to entertain any questions or discussion that any of you might have. You know what? They could hand. Tom, can you hear me? Up in the booth. Is there a handheld mic that we could pass around for people to ask questions, or should I hand them my lapel mic? I think he's bringing one. But if anybody wants to shout a question, we could try that. Very small changes. The question was, have we seen any real changes? And I have to admit that you know, when we convinced the Bush administration to list polar bears as a threatened species, and when Secretary Dirk Kempthorne called all of us and said, you know, I'm in a box. You have convinced me that we have to do this. This is not what I want to do. This is not what the administration wants to do, but I have to do this. And it killed his political career. When he did that, he was no longer considered one of the promising conservative Republicans, as Catherine Hayhoe might have identified him in her speech this afternoon. And I thought that at that time we were going to see some significant action. But we haven't seen very much, and we've missed quite a few significant opportunities. And so the short answer to your question is that we don't see much in the way of leadership. NEPA is starting to apply to some areas of greenhouse gas emissions and things like that, but it's going to be a fight in Congress. The unfortunate thing is that those who are fighting us, they know that this is about physics. And they know that by denying it, they're just hiding their heads in the sand. And I don't quite understand why that would be. But there are some promising signs. You know, I don't know how much good it did, but hundreds of thousands of people marched in cities last December with the big climate march. The Pope is now talking about the threats of climate change to humanity. The military is taking it more seriously. And if you read the material that's posted on the LDS website about stewardship, it directly applies to this. So a lot of important groups, organizations, and people are starting to speak out. And I think that we're on the cusp of a major change. But we haven't seen much of that change yet.
What are some examples of sustainable energies that we should be supporting that would help reduce CO2 emissions the most?
Well, wind and solar are the most important ones. Hydro probably will still play a role. There may be some places that nuclear even is an important part of it. We're at a place right now where there's no easy choices. We've got to stop putting carbon into the atmosphere. And so what are the alternatives? That article that I showed a picture of, that Scientific American in my talk, he claims to have done the math showing that with strictly things like wind, solar, and hydro, we can get out of this if we also employ significant amounts of conservation. And he's not talking about people walking around with a donkey and pots and pans clanging on his back. We're not going back that far, but we're going back to, you know, maybe a lifestyle like we had in the 70s, something like that, only add cell phones to it, you know. You know, there's a lot of opportunities out there. And I should point out one thing that, you know, I said what I'd really like you to do is to use your influence to try and get our elected officials to take this seriously. But there is also a lot we can do ourselves, and we should be doing it. It should start with ourselves and our communities, our churches, our youth groups. What are you doing to minimize your greenhouse gas footprint? Today, Catherine, in her speech, Catherine Hayhoe said it's really useful for everybody to do a carbon footprint analysis. See where you are, see how you can improve on that. There's a recent paper that came out last year that said that if every household in America did everything that they could in terms of walking, riding their bike, taking public transit instead of driving, turning their thermostat down in the summertime and up in the summertime, down in the wintertime, that we could save as much emissions as currently are emitted by the whole country of France. The problem is that I don't see the whole country doing that all at the same time without some guidance from our leaders. So whether we're talking about really major individual actions or more serious actions, it's still going to take leadership. You know, I envision something like the Apollo program where everybody in America was behind changing our ways.
I'm very glad to hear you say that. I spent the last 15 years of my career as a transportation coordinator for a major corporation. And I can't tell you the many, many, many times I was told, even though the company offered free transportation passes on mass transit to employees in that big metro area, they wouldn't use them because it was inconvenient, or it took 10 minutes longer to get home, or it was not going quite their way, or the weather was too bad. I think rather than focusing so much and exclusively on trying to force governmental policies, I think it really begins with us, each one of us. Are we going to forego that extravagant trip? Are we going to turn off the lights when we leave a room? Are we going to recycle containers, which Utah does not do, which it should? All of these kinds of things can help. Are we going to go to the Cougar Eat and take out 5 napkins instead of 2? It just goes on and on and on. That's the way I see it. And it's been going on. So I'm glad to hear you emphasizing that we begin individually and peer pressure by watching others and being a good example goes much, much further than trying to pressure a bureaucrat. That's my view.
Thank you for that. That's some really good points.
I'm curious if you would explain to me the talk about the ice sheets disappearing, which affects the polar bears hunting. What is happening to those seals and the food that they eat? Where are they going? Are those populations also in decline?
The question is what's happening with the seals and I presume the other organisms that were living under the sea ice as the sea ice is declining. And the unfortunate answer is that quantitatively we really don't know. We have a difficult time studying polar bears because they live in faraway places that are hard to get to, but at least polar bears live on top of the ice. The seals live under the ice. They're literally invisible to us for about 90% of the year. People have done some radiotelemetry studies of seals to document their territoriality and how they move and things like that, but there's never been a thorough analysis of numbers or trends because it's just too difficult. If you look at textbooks and papers about ring seals, when they get down to the point where they talk about population size, it usually says numerous. And we know that it's in the many millions, but we don't know how many. But what we do know is that if the polar bears are doing well, the ring seals have to be doing well. And we know that a lot of the changes in the ice are probably not good for ring seals. There's been a couple of papers projecting negative effects, because if the sea ice is freezing up later in the fall, a lot of the snow that would fall on the surface of the ice is now falling into the ocean and melting, and it's not building up on the ice. Then in the spring, when the seals go to create those little caves that I talked about, there's not enough snow. If the pups are born out in the open, they're not only vulnerable to polar bears, they're more vulnerable to Arctic foxes, they're vulnerable even to ravens, and snowy owls go out on the ice and search for them. Gulls, all kinds of animals can take after them, or they can die of exposure when they're out in the open if a real cold snap comes along. So we know that there's lots of things that probably are threatening the seals. We don't know, what the quantitative effect of those things has been. As far as the lower levels of the trophic system, there's some evidence that in some areas we might be seeing greater levels of primary productivity because thinner ice allows more sunlight to penetrate through it, so we might be seeing more algae and things like that. But we don't have any evidence yet that we're seeing that potentially greater primary productivity being transferred up the food chain.
My little sister would like to know what is the ideal temperature for the polar bears and what she can do to help keep it the ideal temperature for them.
What is the ideal temperature for a polar bear? Well, in all of their range, polar bears go through an annual cycle of temperature just like we do. Now, the cycle is at a different range. You know, in the summertime in the Arctic, it's not very warm. But, you know, it can be well above freezing. It could be 40 or 50 degrees Fahrenheit. And then in the wintertime, it's, often 30 or 40 degrees below zero. Tom's been out there trying to camp when it's 40 below zero. That isn't very much fun. The ideal temperature would be the temperature that would retain sea ice over the shallow water areas of the continental shelf. And so the average temperature in northern Alaska now is about 2.5 degrees warmer than it was just 50 or 60 years ago. So a better temperature for polar bears would be, on average, about 2 degrees cooler than it is now. That's a really great comment and question. I'll repeat it. What can we do with groups that we know ought to be concerned about conservation? With groups of hunters and fishermen. I'm a hunter and a fisherman myself, and in fact I got into wildlife mainly because I like to hunt and fish, and I wanted to do what I could to allow future generations to continue to do the same thing. You would think that those groups would have a real serious stake in this, and unfortunately, you are absolutely right. They haven't really addressed this. People like you, who have a big name, who have influence, might be able to raise that topic at various meetings, at the local chapter of the Wildlife Society or places like that, and get the people who are the managers out there talking about it in the field. But there's a lot of citizens groups that are hunters and fishers groups, And, you know, we should really have the National Rifle Association talking about this. But they won't touch it with a 10-foot pole. And I don't quite get that. You know, I don't know for sure that I know the answer, but I do know that it comes about from talking with people who have many shared values and then showing them how those values that you share together are threatened by this. I've talked with people who are grizzly bear specialists, and I've talked with Tom about these conversations, and they've made statements, we're not concerned about grizzly bears with global warming because they live in such varied habitats. You know, this one might dry out and it won't be suitable, but if this one gets a little drier, it'll be more suitable, so they'll move around. And well, that's that uncertainty or proximate effect versus the ultimate effect. Ultimately, if we just let the temperature continue to rise, they'll all be gone. But right now, do we care about grizzly bears in Yellowstone Park or the Northern Rockies? Because those areas are drying out quickly and are likely soon to not be suitable for grizzly bears. So we need to get our own community doing a better job of corresponding and communicating on this. I was talking with one of the premier elephant biologists in the world, and he basically said the same thing that those grizzly bear biologists said. Oh, well, elephants live in so many different habitats. I'm not too worried about them. Well, if they get over the current poaching problem with elephants, then elephants are going to be facing this, because a lot of in the Sahel, south of the Sahara Desert, elephants are suffering from drought right now from climate change. So, you know, it's there. We do need to work with our own groups, and I'd be open to suggestions from you. How do we communicate with some of those groups that we've always been members of and thought that we were aligned with? That's a very good point.
So you mentioned that, you mentioned...
Just a minute, we have a follow-up here. Go ahead, Doug. Yeah.
Time is passing. I'm not as young as I used to be. I don't have the energy that I used to have. And I hope that somehow we can get the younger generation to, through our education systems, and maybe church groups, various church groups, community groups, that the youth seem to catch on to these things much faster than we do at my age. I used to go 18, 24 hours a day working on projects to get a certain position established through a legislature. And one of the ways I found to be successful in that was, you know, maybe just to get people support was you first have to become a friend to them and start a conversation and be sincere about it, and don't always give the impression that you're absolutely on the right track. Maybe they have a good idea and they can tell you better how you can contribute.
Yep. I think that's a really good suggestion. Okay, back there in the corner.
So you mentioned the influence of our leaders in helping tell about climate change, and I saw on the news that they were advising presidential candidates such as Romney not to talk about climate change, and I understand that people might not vote for him, but I'm just wondering why people in current office aren't mentioning and talking about climate change, since so many scientists have confirmed that it's actual, and everyone is in the world is being influenced by it. So why aren't current officers talking about it?
So why aren't our leaders embracing this as a challenge? And I think, you know, that of course is the critical question. I think about that a lot, And I guess I've come to the conclusion that many of our elected leaders are so influenced by people and groups that are actually professionally out there. They're working as professionals, denying that this is a problem, and in so doing, they're deriving short-term benefit from that. There are probably lots of very wealthy people out there who have done the calculation that, well, at least for the next 100 years or so, I have enough resources that I can protect myself and my children, and to heck with everybody else. I'd like to think people don't do that, but I don't have an explanation for it, for this behavior. I think a lot of our political leaders are being duped by people who they trust, but who are misleading them. And you know, we have to get over that somehow. And you know, there are people here in this community who have potential influence with their political leaders. They can sit down and talk with them, talk about those shared values, and talk about what we're concerned about for the future. But it's a challenge. I mean, that's really, like I've said in the answer to the very first question, we haven't seen much in the way of policy level leadership, and that's what we really need to get to. Whether it's going to be somebody standing on a bully pulpit and saying, everybody out there, you need to ride your bike or ride public transit more. You know, I mean, if our leaders were saying that, instead of saying, we don't need public transit because nobody rides it anyway. Well, you know, that doesn't help. That isn't the kind of leadership that helps us very much. The individuals, as this gentleman here said, the individuals that are living, all of us, have to do our part. But it would really help if we had leaders that were providing some guidance. And right now, we don't. Okay, who is next?
I was just wondering, what kind of steps do you think that the nation should take in order to maybe reduce CO2 emissions and help the ice to reform?
Well, I think that the easiest, well, maybe easy isn't the right word, but establishing a fair price for carbon. Just saying we know that the costs, the hidden costs of burning carbon-based fuels, of burning fossil fuels, are really great. Lots of people have been doing studies. What would be a fair price for carbon to compensate for the future damage and even the current damage that's occurring? Establish a price for carbon and then let the market system figure it out. Let the free enterprise system figure it out. And there are a lot of proposals out there for what are called revenue neutral carbon pricing, where all of the revenue goes back to the citizens, but it's applied as a as a tax, essentially, on the emission of CO2, which would encourage utilities and others to quickly convert to other sources. Catherine Hayhoe, in her speech this afternoon, said that in Texas, this spring they had a third, was it? I think she said a third of the power in Texas is generated, as of this last spring, was generated by wind. And that's in Texas, which is like big oil. So, you know, there's a lot of opportunity there. And all we need is a little bit of incentive. And, you know, I'm a real free market guy in most things. I'm a real sort of laissez-faire government guy in most things. I'd like to see less government in most areas. But there are some areas where we need help from the government. And I believe this is one of them. We need help in national defense. We need help from local governments in law enforcement. There's lots of things that we turn to for government that we think of as critical functions. And I think this is one of those. The preamble to our Constitution says that this document was developed to promote the general welfare. And right now, our government isn't promoting our general welfare because it's not giving us any guidance on this topic.
Yeah, I have a couple of points. One is probably out of ignorance, and the question, I have basically two questions. One is the Antarctic a suitable habitat for polar bears, food chain-wise, if they were transported there?
So do you want to give me the second question and then I'll answer them both? Or
Yeah. I'll give you the second one. It's kind of unrelated, but it's I realize that global warming is a big issue here. I spent a couple weeks in Nanjing, China, about a year ago, and I had to wear a face mask in order to survive almost. The pollution is so bad there. If the whole world was like the United States, would we have the problem that we have?
So that's an easy one. Yes, we would. We would still have the problem, but it wouldn't be as severe.
So what can we do about international problems?
Well, I'm a firm believer that many of those countries out there are just waiting for us to take the lead. All across Europe, they're all on board about dealing with climate change. And in fact, if you look at per capita emissions in Germany and France, they're less than half of our per capita emissions. They take conservation much more seriously than we do. Now, their ways of living, their societies are a little bit different. So we can't just say, well, we could easily do that. But I think they're a really good example. I know some Chinese scientists. I visited with them about climate change, and they are convinced that their government is just waiting for the U.S. to take a lead, but they don't want to take the first step. So it's that little that tit for tat kind of a thing. Well, if I do this, is that going to put us at too much of an economic disadvantage temporarily or whatever? But the good news is that there has been, even if it's a weak agreement, and I'm not sure how strong it really is, but President Obama did negotiate a carbon agreement with China earlier this year. It was at least a first step. At least the leaders of the two countries are talking about it. And I think, to answer one of the earliest questions, is that is one of the positive steps that we've seen. Even if it doesn't amount to much, at least some leaders are talking about it at the highest levels. With regard to Antarctica, there's probably not a week goes by that at Polar Bears International we don't get a question, well, why can't we just transplant polar bears to Antarctica? And, I think that if we were to move polar bears down there, they would thrive for a while. And why would they? Because the seals and the penguins that live in the Antarctic, and there are lots of them, haven't evolved for an ice surface predator. The ecological equivalent of the polar bear in the southern hemisphere is the leopard seal. So that preys on them from underneath. So you'll see pictures of people studying Weddell seals or other crab-eater seals, and they're hauled out on the surface of the ice. People just walk up to them and roll them over and paint a mark on them and put a flipper tag in them, and the seals are just like, because they just haven't evolved to be afraid of anything walking around on the surface. Those massive penguin colonies, imagine a few polar bears moving into that. They'd be fat and happy for a while, but after not too long, they'd probably decimate, they'd probably destroy the populations of the prey, and then everything would crash. And, Doug can tell us a lot about wildlife introductions that have gone awry, that have gone bad, and this would be one that would go really bad. Now, there was a question earlier about, go ahead.
How many layers of fat does a polar bear have?
How many layers of fat? Polar bears have just a single layer of fat. They don't have blubber like marine mammals do. A whale has basically 2 layers of fat, and there's a certain chemical and physical structure of that fat that means that we call it blubber. And it has to do not only with insulation, but with shaping the body of the animal to swim through the water. Polar bears don't have that. Their fat is basically like our fat, and it's just a single layer. But on a healthy fat bear, it might be several inches thick.
So you talked a little bit about how the ice retreating affects the hunting of polar bears and that their main food source is the ringed seal. Just a few questions that way. What other food sources would there be for polar bears? And the second question would be, have you noticed any type of behavioral changes as far as hunting goes? And do they hunt differently with the ice melting faster, or just anything that way?
Okay, so the question is about possible alternate foods for polar bears besides ringed seals and bearded seals. And there's two parts to the two answers to that question. One is that regarding other marine foods, there are a few places where there are some alternate foods that, at least in a transient sense, can benefit polar bears. And the polar bear population in Davis Strait, just north of Newfoundland, is a good example of that. As the sea ice has become less and less consolidated and retreated for much of the year, it's no longer very suitable for ringed seals, but it is suitable for gray seals and harp seals. And probably everybody in this room is familiar with the Canadian seal clubbing, where people go out on the ice and hit baby seals and sell the furs. Well, those are the seals that I'm talking about. They're now moving north in some areas into areas where they're available to polar bears, and polar bears have found that, at least in a temporary sense, they might be a suitable substitute. Now, as the ice continues to retreat farther and farther north, we might see this continue for a while, but ultimately, if all the ice goes away, those seals aren't going to be doing very well either. There are relatively few other marine mammals that show much promise to support very many polar bears. Another marine food is the walrus, and particularly Pacific walruses, which occur in very large numbers. You might have seen the news from last fall of I think it was 30 or 40,000 walruses hauled out on the beach near Cape, anyway, Western Alaska. Can't remember which cape it was. Cape Krusenstern maybe. But anyway, large numbers of walruses hauled out. Some polar bears discover those, and a few polar bears are able to feed on those. But one of the things that happens there is that it's not so much the polar bears killing the individual walruses that's a problem for the walruses. It's that the polar bears move in, the walruses stampede, they run over and kill each other, and it's a very kind of a self-limiting process. We don't see that supporting any number of polar bears for any long period of time, but there may be some individuals who benefit from it for a short period of time. So it's, again, a temporary or a transitory kind of a solution. As far as polar bears feeding on land, there's really nothing on land that will support polar bears very well. We have a paper coming out next week on that very topic, hopefully putting to rest the idea that, well, polar bears are going to come ashore and eat goose eggs or something like that. There just aren't enough of them. The timing isn't right, and in most of the range of the polar bear, there isn't opportunity to take foods that are rich enough to support them. Polar bears are the largest of all the bears because of those giant fat pills that they eat. If you look at the grizzly bears that live in the Arctic regions adjacent to where the polar bears live, they're among the smallest of all of the brown bear group and the most widely scattered, because the terrestrial habitat, the land-based habitat in the Arctic, is very poor from the standpoint of a bear. So it doesn't make any sense to think that a whole population of the largest bears in the world could suddenly move on to land and be supported by a habitat that currently only supports small numbers of small bears. Now, you've probably heard of the hybrid thing. There's been, I think, 4, 5, 6 hybrids that have been reported between polar bears and grizzly bears. It looks like this has been going on throughout the evolutionary history of polar bears in areas where their range is adjacent to the range of brown bears. Historically, it probably hasn't meant anything. Does it mean anything now? Well, some people have suggested, well, maybe that's the salvation of polar bears. They'll move ashore and they'll start breeding with grizzly bears. They might do that in greater frequency. They'll get smaller. They won't look like polar bears anymore. Pretty soon what we have is brown bears that have a little bit of polar bear genes in them. Most of us who are concerned about polar bear conservation don't really care about that end game. What we care about is preserving the current life form and the habitat that supports it. And if we do that, the benefits derive to all of us.
Okay, when you showed the map, you showed that the polar bear's habitat wasn't just like in Alaska and Canada. I mean, there were parts in Russia. Like, what are other people doing where they live, like in Russia and other parts of the earth? Like, are there just small pockets of people that understand the issue, or are those countries actually getting involved in doing something about this?
So the question is, what are local people that live in various places with the polar bears doing about it? And in some places, the local people are actually thinking thinking about the future, thinking very progressively about the future for polar bears. But in most places, what they're seeing is that bears are hungrier. They're coming into their villages more. If you're standing on the beach or you're living in a remote Arctic village and suddenly you're seeing more polar bears, your thought might be, oh, well, there's more polar bears. And in fact, right now, we have kind of a really unfortunate and ongoing struggle in communicating with native people in many parts of the North, because they don't believe that climate change is hurting polar bears, even though their houses are falling into the sea because of thawing permafrost. They don't believe it's affecting polar bears because they're seeing more polar bears. Well, a similar situation occurred a few years ago in Tucson, Arizona, when suddenly black bears were showing up with a high frequency on golf courses. Well, that wasn't because there were suddenly way more black bears. It was because it was a few drought years and there wasn't much food in the mountains, and so they came down to where it was green. And but yet, if the only universe you were aware of was that golf course, suddenly you think, oh my God, being invaded by their black bears are coming out the ears. So we have a problem with communicating with local people in many areas. Not in all areas. There's a group called the Alaska Nanook Commission. They seem to be very concerned. But there are many places where we just aren't getting much traction, even with the native people. That's exacerbated or complicated by the fact that over most of the polar bear range, we don't know how many there are or how they're doing. Russia is essentially a black hole with regard to polar bears. They never have done the kind of work that we've done in America or in the West, in Europe. So we really don't know what's going on there. We guess, and what I did in my 2007 projection of what was likely to happen is I made some educated guesses based on what we know about the habitat and what we know about the way the ice moves. But we really don't know what the trend is in a lot of places. So unfortunately, we've got a lot of these remote villages where people might be seeing more bears, but we have no idea what's really going on there. But we do know the habitat isn't as good as it used to be.
Dr. Anstrup, thank you very much. Appreciate it.
Well, thank you for all the great questions. That was fun. Thank you. Good.